The board I have lithium, sodium, and potassium. Lithium, sodium, and potassium. Lithium is 2,1, sodium is 281, and potassium is 2881. So you can imagine the electrons will be entering here. Now we can have one electron here. That's 2 electrons on the lithium, 2, 1. Okay. Now sodium, we're going to have 2 electrons, 8, and then 1. And then potassium, 2, 8, 8, 1. Down the group, let's take group 1. Down this group, the atomic radius is getting bigger. That means the size of the atom is getting bigger because the shells are increasing. Okay, you have to agree with me. Now, how about across the group? So across the group, this is the third period. I'm looking at the third period now. Across the group, okay, we have lithium. Lithium is 2,1. Lithium is 2,1. Beryllium is going to be 2,2. See, the shells are not increasing. We're just adding extra electrons to the same number of shells, 2. Okay? Down the group, we've looked at down the group, atomic radius increases. But across the period, you see, the electronic configuration is just 2 using the, okay, it's 2. So for carbon is 2,4. For this is 2. For nitrogen is 2,5. So you see, it's the same 2 shells. They're just adding electrons, okay? So it's not getting any wider. But you see that the nuclear charge will be increasing. We have 3 protons, 4 protons, 5 protons, 6 protons, 2 plus 5, like that. So the nuclear charge is increasing. Hence, it's going to get tighter. You see from left to right, you can see sodium. This is just one of the periods. This is the third period, okay? Yes. So sodium has an ionization energy of 5.14. Remember, ionization energy is an endothermic. It's an endothermic reaction, so it's positive value. So plus 5.14 kilojoules per mole. So you see, generally it's increasing from to 7.6, with some few exceptions to 8 to 10. So it's basically increasing. It's increasing across the period. This is because it increases due to an increase in the proton number. That's the nuclear charge. Because more protons are being added as you go across from left to right. So it's very difficult for electrons to be lost because ionization energy is described electron removing. So there's more attraction from the nucleus on outermost electrons. So it's the minimum energy required is going to be increasing as you go across from left to right. So it's going to increase to 5, 8, 13 because nuclear charge is increasing. Okay, so the ionization energy decreases down the group because the nuclear charge is reducing even as the atomic radius is increasing. So that attraction between the nucleus and the outermost electrons is getting weaker and weaker because there are more electrons shielding the outermost electron from the nuclear charge, okay, from the charge of the protons. So it's easier for the electrons to go away as you go down the group, okay, generally. All right, let's look at electron affinity. Now, we said electron affinity is the energy released, okay? So it's an exothermic reaction, okay, in kilojoules per mole. That's energy values, and it's negative. Exothermic reactions are negative values, okay? So don't say that minus 349 here is greater than minus 53. No, because energy is released, exothermic reactions are written in negative values. So this a lot of more energy is released than this, okay? So minus 3, the negative sign is just telling that it's an exothermic reaction, okay? So of course, we have some exceptions like magnesium here, but generally, you see minus 53, the values are getting bigger. Just look at the numbers themselves. The negative sign is just to tell you that the energy is being evolved. No, electron affinity is energy released. So these large values here, see, these are the non-metals, your group C, group 7. They are very large, so they love to release they love to gain electrons, okay? Affinity means a love, so a love for electrons, an affinity for electrons. So a lot of energy is released when they gain electrons. Let's continue with the trend for electron affinity down the group. Okay, let's look at down this group 7 group, okay? This group 7. You can see Chlorine is 349, is getting smaller. The energy released, okay? Like I said, this negative is not it is not a mathematical. Don't look at it mathematically. Look at it that the negative is just to tell you that the energy is going out, okay? A lot of energy is released. That's electron affinity, okay? So the energy is reducing. The energy is being released. Why? Because the nuclear charge is reducing, okay? The screening effect is reducing the attraction for electrons.